So, good afternoon, students. The last lecture, uh, we have studied about the sampling, and what we have studied is that when we draw a sample from a population, then we are going for taking out some inferences on the population and how that sample should be collected, and what are the prerequisites and what are the properties of a good sample. So all these things we have studied, and now we will be moving on to the next part. That is, before going for various tests like parametric and non-parametric test. In parametric, we will be learning this Z test, then T test, then F test, and ANOVA. And in non-parametric, we will be studying about this chi-square test. So before going for that, there is one more aspect, that before going for test, we have to make a hypothesis. And after making a hypothesis, then we test that hypothesis. So what is that procedure that is very much required before we actually go for testing sample or a population? So this chapter will be dealing with the testing of hypothesis, and today there will be only one session, and tomorrow, because I am having one lecture in the this winter school organized by the College of Biotechnology. So tomorrow there will be no class, and we will be taking a adjacent or some other time that class. That is the as an extra class we will be taking sometime at other time. So tomorrow there will be no class, and today there will be one session for this. So today we will be going to learn about the tests of hypothesis. So what is this test of hypothesis? So many a time we strongly believe that some results are to be true. That is, we did some experiment, and we find some results, and we believe that yes, these results are true. Okay. So, but after taking a sample, we notice that one sample data does not wholly support the result. Okay, then as we have studied in our last chapter, that it is not necessary that the sample statistics remain the same as that of the population statistic. They may differ from each other. So the difference is due to the original belief being wrong. Okay, either when the sample is saying that the results are not same as you are getting at that time, or your belief as according to your belief. Say, for example, I believe that our LRC farm buffalo give better milk as compared to the farmer. Okay, farmer of the nearby Pabarsa village. What I do, I take some sample of from the this LRC buffaloes, and I take some sample from some of the farmers, randomly selected farmers from the Pabarsa village, and then I milked the animals and found that my original belief, it is not supporting. My hypothesis is not supported because I find that the farmers' buffaloes were giving better milk. So why this might happen? This might happen because maybe possible that my assumption or my hypothesis or my original belief was wrong. Okay? Actually, the farmers' herd was producing better milk as compared to our LRC milk. Or the other way around, this may arise due to the sample being slightly one-sided. That I might have selected those buffaloes from the LRC, those are giving lesser milk, and those of the higher producing milk from the these village sample. So there may be two possibility. Either I was wrong, or maybe there may be some sampling error. Okay. So therefore, for any belief or any hypothesis, we need to have some test which need to identify these two possibility, that whether this difference is due to the sample being slightly one-sided, or due to our wrong belief or our wrong hypothesis. Therefore, what it is given in the next line is the tests are therefore needed to distinguish between the two possibilities. And these tests tell about the likely possibilities and reveal whether or not the difference can be due to only chance. Okay, that is due to only chance, or if the difference is not due to chance element, it is significant. Whether these differences, what we are assuming and what we are getting, these differences are due to chance or whether they are significant, and therefore these tests are also known as tests of significance. Okay, by hypothesis testing, we test the significance of our assumption. Okay, and the whole this whole process is known as testing of hypothesis. Right. So today we will be learning about this, how to set up a hypothesis, how to test. Okay. So setting up and testing hypothesis is an essential part of the statistical. In case of statistical inferences, setting up of hypothesis and testing of hypothesis, the plural of hypothesis is hypothesis. Okay. So hypothesis is an essential part of statistical inferences. So in order to formulate such a test, usually some theory has been put forth. Okay. Either because it is believed to be true or because it is used as a basis for argument but has not been proved. For example, the hypothesis may be the claim that a new drug is better than the current drug for treatment of a disease diagnosed through a set of symptoms. Okay, so we may argue that whatever the new drug we are getting is better than the previous one. Then we have to test it. Then only we can say with the affirmation, yes, rightly said that this is having a significant better outcomes as compared to the drug which we were using earlier. Okay, so in each problem consider the question of interest is simplified into two competing claims or hypotheses. What we do that the question of interest, okay, is simplified into two competing claims or hypotheses, okay, between which we have a choice. The null hypothesis, one will be null hypothesis, okay, one will be null hypothesis which is denoted by H naught, okay, and other will be alternate hypothesis which is denoted by the H1. Okay, so what we do, we simplify our statement or question into two types of hypothesis. One will be null hypothesis and other will be alternate hypothesis, that is the against the null hypothesis. And these two competing claims, okay, or hypotheses are not however treated on an equal basis. Special consideration is given to null hypothesis, and we have two common situations. What are those common situations? That is, first consideration will be your null hypothesis. That whatever the samples you are having or whatever the variation you are having, so in null hypothesis, null means no, means there is no variation. Okay, so what is that? The experiment has been carried out in an attempt to disapprove or reject a particular hypothesis, the null hypothesis. What we do, we make a null hypothesis, conduct the experiment, analyze the data, and our idea is to disapprove that null hypothesis. Thus, we give that one priority so it cannot be rejected unless the evidence against it is sufficiently strong. For example, null hypothesis, there is we are taking an example, we take a null hypothesis that there is no difference in taste between Coke and Diet Coke against the alternate hypothesis H1 that there is a difference in the taste. So what we have taken as an statement that there is no difference in the taste between the Coke and a Diet Coke. Okay, and when we are taking this our null hypothesis, because the name suggests null means no difference, null means no difference. Okay, so whenever we will be taking null, so we have to take no difference, okay, as a default, and other will be against it, that is alternate hypothesis that there is a difference. So for considering this, we have to conduct the experiment. We have to check with the individuals about the taste and note down the readings and then conduct a test to find out that whether the taste of the two, that is Coke and Diet Coke, are same or the different. Okay. Now, if one of the two hypotheses is simpler, we give it priority so that a more complicated theory is not adopted unless there is a sufficient evidence against the one. For example, it is simpler to claim that there is no difference in flavor between the Coke and Diet than it is to say that it is a difference. Right? So always in any experiment, when we say that there is no difference, it is much easier to be claimed as compared to when you say no, there is a difference between these two individuals or these two things. So, generally, this null hypothesis is that there is no difference. Okay. Now, the hypotheses are often a statement about population parameters like expected value and variance. For example, your null hypothesis might be a statement that the expected value, what is expected value? Mean. Isn't it? We have studied in the probability random variable. What is expectation? Expectation is nothing but the mean value. Okay. So your null hypothesis may be that the expected value of the height of 10-year-old boy in Indian population is not different from that of the 10-year-old girl. That is what we want to say is that in Indian population, the height of a 10-year-old boy is same as that of the 10-year girl. And a hypothesis may also be a statement about the distributional form of characteristic of interest. For example, that the height of a 10-year-old boy is normally distributed within Indian population. Also say like this. Okay. So it can either be on the mean value or it can be on the basis of the distribution. Okay. So now we will try to understand that what is a null hypothesis. Okay? So the null hypothesis, which is represented by the symbol H naught, represents a theory that has been put forward either because it is believed to be true or because it is used as a basis for argument. There are two beliefs. Either we believe that our null hypothesis is true, or it is simply being used as a basis of argument so that a experiment could be set. Okay, but has not been proved. But still, your null hypothesis has not been proved. So, for example, in respect of a clinical trial of a new drug, the null hypothesis might be that the new drug is no better on average than the current drug. Okay, again you get the word no, means null hypothesis means negative, that is no difference. Okay, so we are saying that the new drug is no better on an average than the current drug. So we would write H naught is true. There is no difference between the two drugs on average. This is how we write the null hypothesis. Okay. Now we give a special consideration to null hypothesis. And this is due to the fact that the null hypothesis relates to the statement being tested. That is on which we are going to conduct an experiment. Say for example, in this case, that is the clinical trial of a new drug. Based on this statement, we are going to conduct our experiment. And then we are going to find out that whether actually there is a difference or there is no difference. Okay, right. So this is whereas the alternative hypothesis relates to the statement to be accepted if when the null hypothesis is rejected. We do not do anything with the alternative hypothesis. We only test for null hypothesis. If it get accepted, okay, well and good. If it is not accepted, then our alternative hypothesis automatically get accepted. Okay, because our null hypothesis get failed, so our alternative hypothesis will be accepted. As for example, here our null hypothesis was that there is no difference between the two drugs on average. If statistically this get proved, okay, so we get an idea, okay, these two drugs are same. There is no difference on an average. But if this null hypothesis get rejected and we get a difference between the two expected values, okay, significant differences, then we reject this null hypothesis and accept the alternative hypothesis. Okay, now The alternative hypothesis or H1 is a statement of what is a statistical hypothesis test is set up to establish. For example, in a clinical trial of a new drug, the alternative hypothesis might be that the new drug has a different effect on an average compared to that of the current drug. So we would write H1 that the two drugs have different effects on an average. So the alternative hypothesis might also be that the new drug is better on an average than the current drug. In this case, we would write the new drug is better than the current drug on average, right? So finally, what we do on the null hypothesis is that there is no difference, and in alternative hypothesis there is difference, right? So the final conclusion once the test has been carried out is always given in terms of null hypothesis. We either reject a null hypothesis, okay, that is we reject a null hypothesis and favor the alternative hypothesis, right? Okay, after the results we get the results. So what we do, either we reject this null hypothesis and accept this alternative hypothesis, or we simply do not reject the null hypothesis, that is we accept it. So we never conclude that we rejected alternative hypothesis, or even we do not accept the alternative hypothesis. It is the null hypothesis which is to be rejected or accepted. That's all. Okay. So if we conclude do not reject null hypothesis, this does not necessarily means that null hypothesis is true. It only and only suggests that there is not sufficient evidence against the null hypothesis in the given scenario. Got my point? Okay. That it only suggests that there is not sufficient evidence against null hypothesis in favor of alternative hypothesis. So, whereas rejecting the null hypothesis then suggests that the alternative hypothesis may be true. It is not always that your alternative hypothesis is true. Okay, it may be true, right? Now comes your hypothesis testing. Once we get an idea about the null hypothesis and the alternative hypothesis, as I have already told you, that null hypothesis is generally that there is no difference, okay, whereas alternative hypothesis is that there is a difference, right? So what is hypothesis testing? So hypothesis testing is a form of statistical inference, right? A form of statistical inference that uses data from the sample. What we do, we uses the data from the sample, right, to draw conclusion about the population parameter, right? And we draw the conclusion about the population parameter, right? Or a population probability distribution, right? So first a tentative assumption is made about the parameter or the distribution, right? This assumption is called as null hypothesis and it is denoted by H0, and an alternative hypothesis which is denoted by H1, which is the opposite of what is stated in the null hypothesis, is also then defined. Then the hypothesis testing procedure involves using sample data to determine whether or not null hypothesis needs to be rejected. If null hypothesis is rejected, then the statistical conclusion is that the alternative testing of hypothesis H1 is right. So finally, either we have to reject or accept the null hypothesis. So consequently, this your alternative hypothesis will be rejected or accepted, right? A hypothesis is a statement supposed to be true till it is proved false. What is a hypothesis? It is a statement supposed to be true till it is proved false, right? It may be based on previous experience or may be derived theoretically. So first a statistician or an investigator forms a research hypothesis. When we start doing research, so what we do, we make a hypothesis that an exception has to be tested where what is already being known is not generally being tested, okay, or either if it is known then we retest it, that whether in our condition the same results will be obtained, okay. So then what she or he drives a statement which is opposite to the research hypothesis, right? noting as H0. And the approach here is to set up an assumption that there is no contradiction between the believed result and the sample result, and that the difference therefore cannot be ascribed solely to the chance, right? Such a hypothesis is called as null hypothesis. It is null hypothesis that is actually tested and not the research hypothesis, right? That is, in research we believe that okay, by giving this ration we will be getting some better milk, but how we will be approaching, we will be saying that our null hypothesis is that by giving these ration there is no difference in the milk, right? Then we will conduct the actual experiment, take out the samples, see that whether in control when no ration, added ration is given, and when the added ration is given, compare those milk yields and see whether those differences are significant using the various tests. If those comes out to be significant, it means there is difference. So our null hypothesis will be rejected and automatically our research hypothesis will be accepted. So what we here mean to say is that our research hypothesis is nothing but the alternative, right? But what we do in the experiment is we set up a null hypothesis that there is no difference. We start considering that there is no difference, and then we start our experiment. Then we take out these observations, then conduct the experiment, and finally uh, prove that whether null hypothesis is to be rejected or it is to be accepted. Okay, right. So now, if the null hypothesis is rejected, that is taken as evidence in favor of the research hypothesis, because our research hypothesis is nothing but the alternative. And in usual practice, we do not say that the research hypothesis has been proved, only that it has been supported. We do not say that our research hypothesis is proved. We say that it is being supported because our null hypothesis either get rejected or accepted. And when it is rejected, then our research hypothesis is accepted, right? So, for example, assume that a radio station select the music it plays based on the assumption that the average age of its listening audience is 30 years. So, to determine whether this assumption is valid, a hypothesis test would be conducted with the null hypothesis action. That the mean will be equal to population mean will be equal to 30. And what will be our alternative hypothesis? That H1 will be that our mean population will not be equal to 30. Okay, so based on this sample of individual from the listening audience, the sample mean age X can be computed and be used to determine whether there is sufficient statistical evidence to either reject the null hypothesis or to accept, right? Okay, so conceptually a value of sample mean that is close to 30 is consistent with the null hypothesis, while a value of the sample mean that is not close to 30 provides support for the alternative. So what is considered close and not close is determined by using sampling distribution of the X, which we have studied earlier, that is central limit theory. Okay, that is how many standard deviation from 30 we will be considering it close or far, right? Okay, that we have to test. So now ideally, so what I mean to say for example, your mean is I will tell you here, this mean is equal to 30. And we take out the samples. For different samples, we get different mean. So it's when you will be taking different samples, so you will be getting a normal curve, isn't it? What we have studied in your central limit theorem. So when you will be moving some standard deviation from here and here, okay, on either of the side, so you will get far away. So these values will be closer to your 30. These all values will be closer to 30. Whereas when you will be moving far, so these value will be farther from the your mean value. Okay, so how many, after going how many far, we will say that we have enough far from the this mean value 30 that it will be considered that the average age of the listener is not right. Okay, So that we have to test. So ideally, the hypothesis testing procedure leads to the acceptance of this null hypothesis when null hypothesis is true, and the rejection of null hypothesis when it is false. Unfortunately, since hypothesis tests are based on sample information, the possibility of errors must be considered. Okay, we must consider the error because what we have studied in our previous chapter, when we are taking sample, it is not always that you will be getting the mean. We have taken some examples also. That is, some of the samples will be having the population parameter, that is statistic equal to the population parameter, whereas the other will be vary from it. Okay, so when you will be taking sample, it is not necessary that you will be getting the same result, right? So there is possibility of some errors, right? So a type 1 error corresponds to rejecting null hypothesis when null hypothesis is actually true. Say for example, consider a case that actually in population, the average age of the listeners of a radio program is 30. Okay. And you have taken a sample, but you get it, say for example, somewhere around 50, which is very much far away from the 30. Okay. And based on standard deviation, it lies after this three standard deviations. Okay. So ultimately, you will be rejecting your null hypothesis that average age of the listener is not 30, whereas actually in the population it is 30, but your sample is such that you have rejected your null hypothesis, right? So that type of error, when your hypothesis is correct but you reject your null hypothesis, is known as type 1 error. But it is known as type 1, right? And what are type 2 error? You accept the null hypothesis when null hypothesis is actually false. It might be possible. You have considered that average age of the listeners of a population are 30, right? And it is actually not. When you will do the census, you will find that the population, it is somewhere around, say for example, something else. But when you are taking a sample, in that it is coming 30. So ultimately you are going to accept your null hypothesis. In that case, when your null hypothesis is actually false, but after conducting your sampling and test, you are accepting it, those type of error are known as type 2, right? And these type 1 error and type 2 error are generally being asked in your question paper. Okay. So the probability of making a type 1 error is denoted by alpha. So how this type 1 error are being denoted? Type 1 error are denoted by alpha, whereas your type 2 error are denoted by beta, isn't it? Right. So your type 1 error is denoted by alpha, okay, and your type 2 error are denoted by gamma, right? So in using the hypothesis testing procedure to determine if the null hypothesis should be rejected, the person conducting the hypothesis test specify the maximum allowable probability of making type 1 error, which is called as level of significance of the test. Okay, so when you are conducting the test, okay, so you have to specify that how much type 1 error you can commit in your test. Okay, how much type 1 error or the probability can commit type 1 error. And what is a type 1 error? That you actually, what you did in type 1 error, that rejected null hypothesis when it is actually true, isn't it? You have rejected the null hypothesis when it is actually true. What is the probability of this thing? Okay, so that probability is known as level of significance. that how much type 1 error, what is the probability of committing the type 1 error in your experiment. It is known as your level of significance of that, right? So, common choice for the level of significance is 0.05 or 0.0. So, what is it? Say, for example, you have a distribution of listeners whose average age is 30. Okay. So, these all listeners constitute your 100, isn't it? Or the probability equal to, and how you can get that if you go for this mu plus minus 3 standard deviation, so you will be getting 99% of the population sample, isn't it? So only 1% will be outside your 1% will be outside your frame, that is outside your this. So any population distribution which corresponds to this type, that is having mu equal to 30 and 99% of the individual, and it will be having some standard deviation. So if any sample which is having such distribution is being represented to you, will be accepted. So this 1%, this 1% will be rejected. Okay, and sometimes we put this at the 5%, that is up to 95% we accept, and that 5%, these 5%, say for example, and these 5%, say for example, these samples we, okay, so this 95%, this 95% becomes our confidence, right? So although most application of hypothesis testing controls the probability of making type 1 error, they do not always control the probability of making the type 2 error. This point should be noted that most of the test, what we consider or what we fix is alpha. We do not fix the beta. Okay. So beta is self. That is means it is not under the control of the experiment. Okay. What we control is the type 1 error, that we should not reject the null hypothesis when it is actually true. So when we will be committing this to be, say for example, 5%. So in our 95% of the samples, okay, we will be holding this true, right? And in 5% chances are there that we may reject the null hypothesis when it is actually okay, as per the probability of the distribution of the samples, right? So basically, we have a control over the type 1 error, but we do not always have control over the probability of making the type 2. So a graph known as an operating characteristic graph can be constructed to show how the changes in the sample size affect the probability. This is beyond our syllabus. So, however, we can also calculate this, how much, once we have defined the alpha, we conduct the test, then we can find out that how much beta we will be committing, right? So, a concept known as p-value provides a convenient basis for drawing conclusion in hypothesis testing. Okay, p-value is nothing but the probability of committing type 1 error. Okay, so the p-value is the measure of how likely the sample results are, assuming the null hypothesis is true. The smaller the p-value, the lesser likely are the sample results reliable. Okay, if the p-value is less than the alpha, the null hypothesis can be rejected. Otherwise, the null hypothesis cannot be rejected. The p-value is often called as the observed level of significance for the test. Okay, what is there? That, say for example, if we have a p-value which is greater than this 5%, okay, so we will not be rejecting your null hypothesis. It will only be rejected when it goes below that. Okay, So hypothesis test can be performed on the parameter of one or more population as well as in variety of other situations. So in each instances, the process begins with the formulation of null and the alternative hypothesis about the population. In addition to the population mean, hypothesis testing procedure are available for population parameters such as, so you can, I have told you about this mean, but you can also test the population for proportions. You can also test the population for variances. You can also test the population for the standard deviations, and you can also test them for these medians. Okay, so hypothesis tests are also conducted in regression and correlation. Okay, you can also test the regression and the correlation analysis. Okay, so to determine if the regression relationship and the correlation coefficient are statistically significant, that is the outcome y depends on the x, but whether it is significant, that this x is significantly affecting the y or the results of the y. Okay, so that can be done using this hypothesis test. So a goodness of fit test refers to a hypothesis test in which the null hypothesis is that population has a specific probability distribution, such as a normal probability distribution. Okay? And non-parametric statistical method also involves a variety of hypothesis testing procedures. So generally here what we do is that we assumes that in doing this test that this population follows a normal distribution, because our this alpha and these all these things depends on this normal distribution. Okay, so for example, if it is assumed that the mean of the weight of the population of a college is 55 kg, right? That is, for example, in veterinary we have a average weight of 55 kg. Then the null hypothesis will be that the mean of the population is 55 kg. That is, your H naught will be H naught. Okay? This mu will be equal to 55 kg. That is null hypothesis. In terms of alternate hypothesis, it will be H1 mu naught is not equal to. Okay? Or in that case, H1 can be greater than, or if this H1 can be lesser than 50. Now, fixing the limit totally depends upon the accuracy we desire. And we have already this told you that level of significance. So generally the limits are fixed such that the probability that the difference will exceed the limit is 0.05 or 0.01. So these levels are known as level of significance and are expressed as 5% and 1% level of significance. Okay. So rejection of null hypothesis does not mean that the hypothesis is disproved. It simply means that the sample value does not support the hypothesis. So when you take out the samples and those samples, if in more than 5% of the cases, say for example, you take out the samples and it is observed that distribution of those samples in more than 5% of the cases it does not follow the original population, it means your null hypothesis will be rejected, isn't it? So therefore these are known as level of significance, but it does not say that this population means this is proved. It is simply that the samples are not supporting this. Whatever sample you have taken is not supporting your, right. So the limits or range within which the hypothesis should lie with a specified probability are called the confidence limit or fiducial limits. So it is customary to take these limits at 5% or 1% levels. If sample values lies between these confidence limits, the hypothesis is accepted. If it does not, the hypothesis is rejected at that specified level of. Okay. So now we will be just try to understand few more concepts. That is, one will be errors in testing of hypothesis. Okay. What are the different errors in testing of hypothesis? So in testing of any hypothesis, we get only two results. That is, either we accept or we reject it. That null hypothesis, either we accept the null hypothesis or we reject. So we do not know whether it is true or false. Hence, there are four possibilities. That is, we are making a statement, but we do not know now that that statement is true or false. Okay. And ultimately, after taking out the samples and conducting a test on it, we are going to either accept it or reject it. Okay. So there will be four possibilities arises. The hypothesis is true, but test rejects it. So it will commit type 1. Hypothesis is false, but when you take out the sample and conduct a test, it accepts it. So it commits type 2 error. Hypothesis is true and test accepts it is a correct decision. And the hypothesis is false and test rejected, it is a correct decision. So how this can be shown? So we have already discussed this thing and this is only being described here. So you will be better understood. So this is your null hypothesis. This is your alternative hypothesis. And this is the truth. Say for example, your null hypothesis and you reject null hypothesis. So it will commit the type 1 error. So your decision is to reject the null. But if your decision is to accept the null hypothesis when it is true, so this is your right. Your decision to reject the null hypothesis when it is not true, your alternative hypothesis is true, then it is your right decision to reject the null hypothesis because your alternative hypothesis. And your decision to accept a null hypothesis when it is not true, if you are going to commit the type 2. Okay, so a type 1 error is often considered to be more serious, right? Your type 1 errors are more serious and therefore more important to avoid than type 2 errors. So the hypothesis test procedure is therefore adjusted so that there is guaranteed low probability of rejecting the null hypothesis wrongly. This probability is never zero, cannot make it zero. And this probability of type 1 error can precisely be computed as P or type 1 error is equal to significance level is equal to alpha, which we have already. Okay. So the exact probability of type 2 error is generally unknown. If we do not reject the null hypothesis, it may still be false. A type 2 error, as the testing of a hypothesis sample may not be big enough to identify the falseness of hypothesis, especially if the truth is very close to the hypothesis. So for any given set of data, type 1 and type 2 errors are inversely related to each other. The smaller the risk of one, the higher the risk of other. Okay? For any given data, type 1 and type 2 data are inversely related to each other. And for any given set, the smaller the risk of one, the higher the risk of other. A type 1 error can also be referred to as an error of first kind. It is also known as error of first kind. Now, type 2 error. So, in a hypothesis test, a type 2 error occurs when the null hypothesis is not rejected when it is in fact false. For example, in a clinical trial of new drug, the null hypothesis might be that the new drug is no better on an average than the current drug. And so, therefore, your null hypothesis will be there is no difference between the two drugs on an average. A type 2 error would occur if it was concluded that the two drugs produce the same effect. That is, there is no difference between the two drugs on an average, when in fact they produce the difference. Okay, so a type 2 error is frequently due to sample size being small. If your sample size is small, okay, then you are ought to commit this type 2 error. And the probability of type 2 error is symbolized by beta and is written as P. Type 2 error is equal to beta, but is generally unknown. Okay. And a type 2 error can also be referred to as error of second time. Error of second. Okay. So, hypothesis testing refers to the process of using statistical analysis to determine if the observed differences between two or more samples are due to random chance. Whatever difference you are finding are either due to random chance or true differences in the samples as stated in the alternative hypothesis. So what we are exactly finding whether the differences are simply by random chance or these are really true differences. Okay. So in null hypothesis is stated assumption that there is no difference in the parameter. Okay. Mean variance. Okay. Of the two population DPMO. Then the alternative hypothesis action is a statement that the observed differences or relationship between two population is real and not the result of the chance of an error in the sample. Right? Okay. So, what is alternative hypothesis? That the observed differences or relationship between two population is real and not the result of chance or an error in the sampling. This is your alternative. Yes. Okay. So, hypothesis testing is the process of using a variety of statistical tools to analyze data and ultimately to fail or to reject the null hypothesis. So, from a practical point of view, finding statistical evidence that the null hypothesis from practical point of view, finding statistical evidence that the null hypothesis is false allow you to reject the null hypothesis and accept the alternate. Right? So, because of the difficulty involved in observing every individual in the population for research purpose, researchers normally collect data from sample and then they use the sample data to help answer question about the population. So a hypothesis test is a statistical method. What is a hypothesis test? It is a statistical method that uses sample data to evaluate a hypothesis about a population parameter. Okay, and the hypothesis testing is standard and it follows the specific order. What is that order? First, state the hypothesis about the population. Say, for example, a population parameter like mean, variance, or something. Then obtain a random sample from the. Okay, first of all, what you have to do? You have to state a hypothesis. Then, what you have to do? You have to obtain a random sample from the population and also find its mean. And then compare the sample data with the hypothesis on the scale. Say, for example, you use Z test or the normal distribution, okay, or T test or chi-square test or F test. And then you have to compare that sample data on the scale sums. Then a hypothesis is typically used in the context of research study, and researcher complete one round of field investigation and then use hypothesis test to evaluate the result. Depending on the type of research and the type of data, the details will differ from one research situation. Okay. So we will be just discussing three what are the steps involved and what are the different situations in which we use the basic hypothesis. Okay. Now, basic experimental situation for hypothesis. Okay, what are the basic experimental situations? It is assumed that the mean mu is known before that is the population mean is known. Okay. The purpose of the experimenter is to determine whether or not treatment has an effect on the population mean, right? A researcher will like to find out whether increased stimulation of infants has effect on their weight. Okay, if we stimulate the more infant, then whether there is effect on weight. It is known from the national statistics that the mean weight of a 2-year-old children is 13, and the distribution is normal with the standard deviation sigma is equal to 2 kg. We have already these parameters. Okay. Now he wants that if we stimulate these infants, whether there is any difference. So to test the truth of the claim, a researcher may take 16 newborn infants, say for example, and give their parent detailed instruction for giving these infants increased handling and stimulations. So at age of 2, each of the 16 children will be weighed and the mean weight of the sample will be computed. Now, the researcher may conclude that the increased handling and stimulation had an effect on the weight of the children if there is substantial difference in the weight from the population mean. So what they will be comparing? They will be comparing the standard deviation of that sample and the population mean. If it is substantially being different from that of the population that it resides outside, say for example, I will try to make you understand this thing using an example. Say, for example, we have a population in which we have this mean as they have given 13 kg, right? And a standard deviation equal to 2 kg. So, at one sigma difference, it will be on this side, it will be 11, and on this side, it will be 15. At 2 standard deviation, it will be something like 9 kg, and it will be like something like uh, plus 2 is 17 kg. And on 3 standard deviations, it will be something like, say, for example, 7 kg, and on this side, it will be something like 19 kg, right? Okay. Now, if we have taken a sample out of this population, we have made this graph for a population, and out of this we have taken around 16 children, right? And we plot the parameters again. Okay, so not here. Okay, we get, say for example, of these 16, we get an graph like this, say for example, such that their mean lies somewhere in this, that is 7, the sample we have obtained from it. Okay, and it has a standard deviation of say for example sigma is equal to 1, right? So it will be 8, 9, and 3 standard deviation 10, and it will be somewhere, this will be 6, 5, and 4, from 4 to 10 kg, this sample was. Okay, so it will be outside this 5% level, isn't it? That is at 3 standard deviation, it will go up to 99% will be here. Okay, so this 7, which is the mean of the new sample, is very much far away from your 13 kg to a level that it goes beyond your this 95%. That is alpha is equal to 5. Okay, that is 100 minus 5 is 95. So it is beyond this value. So when it is beyond this value, we can say that this sample significantly differs from that of the population. So we will disapprove our null hypothesis that there is increase in the weight, okay, by stimulation on the sample. So this is how we test. So we have to see that how much far from the actual mean value our new sample mean value is. If it is more than uh, uh, this 3 standard deviation away, okay, so it means that it crossed the 99% level and it goes to the 1%, which is less than the 5%. So this will be your null hypothesis will be rejected. So what are the steps involved in hypothesis testing? So state the null hypothesis and the alternative hypothesis. Note, the goal of inferential statistics is to make general statement about the population by using sample data. Therefore, the testing hypothesis, we make our prediction about the population. Now, set the criteria for a decision. Then set the level of significance, alpha level. Okay. And then critical region. Okay. That is the region composed of extreme values that are very unlikely outcomes in the null hypothesis is true. So the boundaries for the critical region are determined by the alpha level above. Collect the data, compute the statistic using the formula, make a decision and write down the decision. That whether you accept the null hypothesis or rejects the null hypothesis. So I can see that there is no questions in the chat box. And this completes our hypothesis testing. Tomorrow we will not be having a class. We will adjust the class somewhere else, some other day. Okay, so this is all for today from my side. So this completes your test of hypothesis, right? And these notes are available at your website also, so you can go through them. So thank you very much for your patience hearing. Thank you.